Jane, all of you. Today we are going to study the chapter electricity. First of all, we will see what is electric current. Electric current. Electric current is the rate of flow of charges through a conductor, or it is the amount of charge flowing through a conductor. The flow of charges is the flow of electrons, and the electrons moves from negative terminal to the positive terminal. But the direction of the current is taken from positive terminal to negative terminal. That is opposite to the direction of the electrons. The path which allows the flow of current is called the circuit. The circuit can be open and closed. Now, the closed circuit means it allows the flow of current, and an open circuit means it stops the flow of current. Current is given by the formula charge upon time. Current is denoted by the letter I, and I is equal to Q upon T, where Q is the charge and T is the time. The SI unit of current is ampere, and SI unit of charge is coulomb. 1 coulomb means 6 into 10 to the power 18 electrons. Now, 1 ampere is equal to 1 coulomb per second. There are smaller units of current, that is milliampere and microampere. 1 milliampere is equal to 10 to the power minus 3 ampere, and 1 microampere is equal to 10 to the power minus 6 ampere. And the current is measured using an instrument called ammeter. Ammeter is always connected in series. So this is about current. So I told you current is the rate of flow of charges, and the formula of current is I is equal to Q upon T. Now, in order to have a flow of current, one thing is important, that is potential difference. Now we will see what is potential difference. Potential difference is the amount of work done to carry a unit charge across the conductor. That means in order to carry a charge across the conductor, we have to do some work. And that work is the potential difference. Or we can say potential difference is equal to work upon charge. Potential difference is denoted by the letter V, and work is denoted by the letter W. So V is equal to W upon Q. The SI unit of potential difference is volt. So 1 volt is equal to 1 joule per coulomb. Potential difference is measured by using an instrument called voltmeter. And this voltmeter is always connected in parallel. So now I will show you the diagram here. So here we can see how it is connected. So this is an electric circuit. This is battery. This is the bulb. This is the plug key, and this is the ammeter. Here ammeter is connected in series. Now next we are going to see is Ohm's law. So now we will see what is Ohm's law. Ohm's law means it gives a relation between current and potential difference. Or we can say that according to Ohm's law, the current flowing through a conductor is directly proportional to the potential difference between the ends of the conductor, and one condition is that the temperature should remain a constant. V is proportional to I. That is the mathematical formulation of the law. And in order to remove the proportional sign, we have to put a constant. So V is equal to IR, where R is the constant of proportionality, and it is known as the resistance. And the resistance remains a constant only when the temperature remains a constant. That is why in the Ohm's law we say that the temperature should remain a constant. Now we will see what is resistance. So resistance is the property of a conductor to oppose the flow of current through it. And according to Ohm's law, R is equal to V upon I. And the SI unit of resistance is Ohm. Now R is equal to V upon I means the current is inversely proportional to the resistance. So when you increase the resistance, the current will decrease, and when you decrease the resistance, the current will increase. Now, the resistance depends on few factors. That is, the length of the conductor, the area of cross-section, the material of the conductor, and the temperature. First, we will see the material of the conductor and the temperature. If you change the material, the resistance will also change. If you change the temperature, then also the resistance will change. Now, other two factors are length and area of cross-section. Resistance is directly proportional to the length of the conductor or length of the wire. That means if you increase the length, the resistance will also increase. And if you decrease the length, the resistance will also decrease. Another factor is the area of cross-section. Resistance is inversely proportional to the area of cross-section. So when you increase the area of cross-section, the resistance will increase. Resistance will decrease. And if you decrease the area of cross-section, the resistance will increase. So these are the factors on which the resistance of a conductor depends. Now we will see the length and area of cross-section. R is proportional to L and R is inversely proportional to A. When you combine these two, R is proportional to L upon A. So here, in order to change the proportional sign, we put a constant, that is resistivity or rho. So we can write R is equal to rho L upon A. Whereas rho is the constant of proportionality called the resistivity. Resistivity depends only on two factors. One is the material and the other is the temperature. That means resistivity is specific to a given material. That is why it is also known as specific resistance. And the SI unit of resistivity is ohm meter. So this is resistivity. So the difference between resistance and resistivity is resistance depends on the length and area of cross-section, whereas resistivity does not depend on the length and area of cross-section. So these are the few topics that we have covered today. That is resistance, then resistivity, potential difference, current. Or we can say current, potential difference, Ohm's law, resistance and resistivity. Hope you have understood the topics clearly. Thank you.